Welcome back to the Deep Dive. We are jump straight into some pretty big news today. Contentious stuff, actually. We're talking Ferrari.
The big one.
For years, maybe a decade, they've been seen as, the ultimate defenders of the internal combustion engine. The V12 standard bearers.
Absolutely, the ones who'd fight to the end.
And yet, here we are. They've announced the Electric, their first all-electric car. And it's a four-seater sort of SUV style thing.
Quite the pivot.
So our mission today is to try and, put the emotion aside for a bit and really dive into the engineering, the nuts and bolts of this machine.
Yeah, look under the hood, so to speak.
Exactly.
Yeah.
What did they actually build? What compromises did they make? Did they manage to keep that, Ferrari soul? Or is it just genius engineering forced by circumstance?
Well, for a lot of their fans, it definitely feels forced, a capitulation, like you said. And you have to remember the history here.
Right.
Think back maybe 10, 12 years ago. The LaFerrari launch. That car had a hybrid system. It could run electric only.
But they didn't let it.
No, they deliberately disabled that mode. Said publicly, we're not interested in electric driving. They planted their flag firmly in the IC camp.
And compared to rivals, the reaction seems much stronger. Porsche, Bugatti, Lambo, they've handled electrification differently, haven't they? More gradually, maybe.
Definitely. Porsche has great hybrids, some shared EV platforms. Bugatti just showed off a huge V16 hybrid. They sort of eased into it, kept some of that IC drama.
So Ferrari gets the heat because they were the holdout, the symbol of tradition.
Exactly. They were the hope for people who love traditional engines. So when they suddenly announce a four-motor electric SUV, well, the reaction is going to be strong, but the engineering story itself is pretty remarkable when you dig in.
Okay, let's do that. Let's unpack the core mechanics.
Yeah.
4 electric motors, 1 for each wheel.
Yeah, all in a performance, definitely. A bit overkill for an SUV-style car, maybe. But then again, they put a V12 in the purest sewing, so...
Fair point. Consistent excess, perhaps.
Yeah. And all 4 motors are PSMs, permanent synchronous motors.
Okay, so they use magnets internally. Why is that choice surprising? For you listening, why not just use the most powerful type?
Well, the thing is, usually if you want efficiency, especially the ability to completely shut off the front motors for two-wheel drive mode to save battery.
Right, which they claim they can do.
Exactly. You'd often see ESMs used, electrically excited synchronous motors. With ESMs, you create the magnetic field with electricity, cut the power, the field disappears, the motor spins freely, no drag.
But with PSMs, the magnets are always magnetic, always interacting. So even if you're not sending power, the wheels turning the motor shaft feel resistance, right? Like a permanent drag.
Precisely. Those internal magnets are always interacting with the stator, creates parasitic drag. It basically forces you into constant all-wheel drive, which isn't great for efficiency.
Yet Ferrari says, no problem, we have a two-wheel drive mode. So how?
This is where the clever engineering comes in. They had to add a reduction gearbox, a gear set between the motor and the axle.
Ah, so it's not just the motor design, it's the connection.
Exactly. Inside that gearbox, there's a clutch mechanism. They can physically disconnect the motor's output from the wheel drive shaft.
So the motor might still spin a little from the wheel motion, but it's not fighting that strong magnetic field against the stator in the same way, and crucially, it's not transmitting that drag back.
Well, it effectively isolates it. It stops the power transmission path and significantly reduces that drag associated with the PSM design when coasting or in 2WD mode. It's a complex, probably expensive way to get the best of both worlds. PSM power, but ESM-like efficiency potential.
Okay, elegance through complexity. Now, power distribution. They clearly wanted that rear drive feel, even with 4 motors.
Oh, absolutely. They stack the power at the back. The front axle gets about 282 horsepower combined.
Okay.
The rear axle, a massive 831 horsepower.
Wow. So it's overwhelmingly rear-driven in feel.
Should be, yeah. Designed to handle like a proper sports car, not, some front-heavy appliance.
Right. But now, the torque figures. This caused a bit of a stir in the sources we looked at. They announced, 8,000 Newton meters rear, 3,500 front.
Yeah. Astronomical numbers, and honestly, it's marketing spin, plain and simple.
How so?
Those huge figures are wheel torque. That's the torque after it's been multiplied by the reduction gearbox. The sources suggest that gearbox has maybe an 8-to-1 ratio.
Wait, so explain that for listeners. It's like quoting your running speed in inches per minute to sound faster.
That's a great way to put it, yeah. Car companies usually quote engine torque, at the crankshaft before any gear multiplication. Ferrari's quoting the final number at the wheel. It's misleading.
Because internal combustion cars aren't quoted that way.
Never. If you do the math backwards, the actual motor torque for that 831 horsepower rear setup is probably around 1,000 Newton meters. Still very, very high, but not 8,000.
So the power is real. The number they shouted about was massaged for headlines.
Pretty much sums it up, prioritizing shock value over clear comparison.
Okay, let's move on to the motors themselves. They're apparently leveraging F1 tech here, making them super efficient.
Yeah, the specs are pretty wild. Front motors spin up to 30,000 RPM.
30,000.
And the rears hit 25,500 RPM. Now, that difference, plus the fact they can disconnect the front, means they need different gear ratios front and rear. Probably something like 1 to 8.5 at the front, 1 to 8 at the rear, just to make sure the wheels turn at the same speed when needed.
But the efficiency number, that really stood out. 93% efficient at maximum power.
It's huge, really huge. Most performance EVs are what, 80, maybe 85% efficient when you're really pushing them. Getting to 93%, that takes serious R&D.
How'd they manage that?
Lightweight stuff like carbon fiber components in the motor itself, apparently. And really optimizing the magnet setup using something called a Halbach array to focus the magnetic field better. Makes the motor smaller, more power dense, and cuts down those electrical losses.
Why push so hard for that extra few percent? Why spend so much effort getting from, say, 85 to 93?
Because weight and heat are the enemies here. They've got this heavy EV platform, 4 motors, big battery. They need every efficiency gain they can get.
Ah, so less wasted energy means less heat to manage?
Exactly. Less heat means a smaller, lighter cooling system. More efficiency also means more range from the battery, or they can use a slightly smaller, lighter battery for the same range. It all feeds into trying to make this SUV handle like a Ferrari should. It's the price of admission, really.
Right, the battery then. They developed their own pack, didn't just buy standard modules off the shelf. What advantage did that give them?
Density. They hit 195 watt-hours per kilogram. Weight kg.
Okay, put that in context for us.
Well, the industry average is maybe around 160 weight kgs. Tesla, who are pretty good, are maybe closer to 170, so 195, that's a big jump, like 15, maybe 20% more energy packed into the same weight.
Which means for the same total energy, the battery pack is significantly lighter.
Correct. And weight is everything for handling. So they traded the cost savings and simplicity of off-the-shelf parts for maximum lightness.
Makes sense. And they also had a packaging challenge, right? Trying to keep the car feeling sporty, not like a long limo.
Yeah, they didn't want that long wheelbase Grand Tour feel. They wanted it shorter, more agile.
So how did they fit enough battery capacity in?
Clever stacking. They used a double layer of battery cells, but only under the rear passenger seats.
Ah, so taller just in that one section.
Right. The rest of the floor has a single layer. It lets them cram in more energy without making the whole car excessively long or raising the floor height everywhere. Oh, and it uses 800-volt architecture, of course. That's kind of the standard now for fast charging.
Okay, so custom motors, custom battery, complex drivetrain.
Yeah.
It all points to trying desperately to manage the weight and feel. Which brings us to suspension. A Ferrari hallmark. How did they adapt that for this heavy EV?
They're using a really sophisticated active system, similar ideas to the Prancing, but, adapted. Inside the suspension units, there's a ball screw mechanism.
A ball screw, what does that do?
It acts like a second active spring. It's not just about adjusting damper fluid like normal adaptive suspension.
So it can physically push or pull, change stiffness on the fly.
Instantly. In milliseconds. It can actively counteract body roll in corners, prevent the nose from diving under heavy braking, which is crucial with the weight and regen braking of an EV. It can change right out incredibly quickly, too. Yeah. Far more adaptive than just tweaking oil flow.
And I even measured the damper oil temperature.
Yeah, to constantly adjust the damping because oil viscosity changes with temperature. They want absolutely consistent performance. It's pure race car thinking applied to managing physics in a road car.
Plus, with 4 motors, you get incredible torque vectoring, right? Shuffling power side to side.
Exactly. Sending power precisely to the wheel that can best use it for turning or grip. Another tool to help mask the car's mass and make it feel agile.
Okay, but here's where it gets weird. All this tech to maximize connection and feel, and then they do something that seems totally opposite. They isolate the rear subframe.
Ah, yes.
Okay.
The isolation paradox. It's a choice.
Explain that. What's the subframe and why isolate it?
So the subframe is the structure that holds the rear motors, the suspension parts, the gearboxes. Basically, the whole rear axle assembly.
Right.
In this car, that whole structure is attached to the main body, the chassis, using flexible rubber bushings, insulating materials.
Why?
To reduce noise and vibration coming into the cabin, make it quieter, more comfortable, less road rumble, less harshness.
Wait, isn't feeling the road, feeling what the rear axle is doing, kind of the point of a performance car? Like a BMW M car often has the rear subframe rigidly bolted or even welded to the chassis for maximum feedback.
Exactly. That rigid connection transmits every little vibration, every nuance of grip or slip directly to the driver's seat. It gives you that tactile connection, crucial for feeling confident at the limit.
So why would Ferrari deliberately mute that connection?
Their justification, according to the source material, was telling. They basically said, look, we don't have a loud V12 engine anymore to drown out other noises. The vibrations from these powerful electric motors could be irritating to passengers, so we've isolated them.
Wow. So they're admitting the electric powertrain noise isn't pleasant, and instead of fixing that, they're sacrificing driver feedback for passenger comfort.
That seems to be the implication, choosing refinement over raw connection. It kind of sums up the core conflict of this whole car, doesn't it? Engineering brilliance used to filter out the very sensations that traditionally define the brand.
Yeah, it really does. And that filtering leads us straight into the next big controversy, trying to replicate the emotional experience, starting with sound.
Right, because the silence, or maybe the whine of electric motors, isn't exactly stirring the soul like a V12. They apparently rejected just pumping fake, synthesized engine noises into the cabin like some rivals do.
Okay, so what's their solution?
It's clever, but debatable. They put accelerometers, basically vibration sensors, directly onto the motor housings.
To capture the actual sounds the motors make.
Exactly, the real organic whirs and hums, but then they take that raw sound signal and process it heavily.
Like an audio engineer mixing a track?
Kind of, yeah. They filter out frequencies they deem unpleasant or harsh, and they enhance the frequencies they think sound more exciting or powerful. Then they broadcast that processed, curated sound into the cabin.
So it starts real, but gets manipulated quite a bit before you hear it.
A lot. The argument in the source material is, once you filter and shape a sound that much, is it still fundamentally real, or is it just a very sophisticated imitation? They're essentially manufacturing an emotional response from a real source signal.
Manufacturing emotion.
Yeah.
That theme continues with the shifting feel, doesn't it? Because the EVs don't have gears to shift, just smooth acceleration, which Ferrari apparently finds boring.
Yes, boring if your brand is built on driver engagement. So there's no actual transmission with different gear ratios.
Right.
The paddle shifters behind the steering wheel, they don't change gears, they change the torque map.
How does that work?
When you pull the plus paddle for an upshift, the car's computer delivers a programmed sudden increase in torque, a little surge. It simulates that feeling of punching into the next gear, that shove in the back.
So software creates a little bump in the acceleration curve just to feel like a gear shift.
Exactly, just for muscle memory and sensation.
Right.
And when you pull the paddle to downshift, it increases the regenerative braking force quite sharply.
Mimicking engine braking.
Precisely. They're layering these artificial sensations, the processed sound, the fake shifts onto the smooth, continuous reality of electric power. It's brilliant engineering, no doubt, but it's engineering designed purely to simulate something they chose to remove.
So let's try and wrap this up. Looking at the whole picture, it's an incredible technical achievement, isn't it?
Undeniably.
You've got these custom 93% efficient motors spinning at insane speeds, a proprietary battery with class-leading density, 195 kWh, that super advanced active suspension system.
Real cutting-edge stuff.
But it feels like almost every bit of that brilliance was spent solving problems created by going electric in the first place. Managing weight, managing heat, managing sound.
And then spending even more effort trying to simulate the feel of the V12 they left behind.
Yeah. And the market context seems to back up this tension. The sources we looked at suggest that initial hype for super fast EVs, the hyper EVs, might be fading a bit.
It seems so. That insane straight-line acceleration, it's becoming more common even in fast sedans. It's not quite as exotic anymore.
And the people spending huge money on hypercars are maybe realizing they want more than just speed. They want the noise, the vibration, the drama of combustion.
That seems to be the trend mentioned. The emotional connection, the visceral experience is becoming the key differentiator, again, at the very high end.
So, for you listening, what does this all mean? We've dissected an engineering marvel, yes, but maybe one born more out of necessity, out of regulations and market shifts, than pure passion for the electric drivetrain itself.
It certainly feels that way. Which leads to, I think, the really provocative question for you to think about after this.
Go on.
If a brand like Ferrari, a brand built entirely on raw, visceral, almost untamed emotion, if they pour all this technical genius, all this money into creating something that is, at its core, trying to perfectly imitate the feeling of its own past, does the brilliance of the underlying engineering even matter if the final experience feels like a highly polished, highly filtered copy? Is technical perfection enough to replace the soul they seem to have deliberately isolated?
Wow. Is the perfect imitation worth as much as the flawed original? A very challenging thought to end on. That's all the time we have for this deep dive. We'll see you next time.